All right. Well, thank you, everyone. My name is Amy. I am a back-end engineer, and I'm here to talk about knobs, buttons, and switches that you can add to your application to change its behavior when things are going wrong. So we all know, we've all seen applications that keel right over the second a single unimportant downstream service goes down, and so let's not have that be you. Can I do that? Excellent. So pilots operate their planes with an array of knobs and buttons to be able to react to changing climates around them. Captain Kirk could shout every week about diverting power to the shields. So I want you to have the tools to feel like you have that level of control in your application when the going gets rough. So this is a talk about application resilience. But it's a talk about only one portion of it. When we talk about application resilience, we usually talk about different levels of big problems, small to big problems that can happen to your application. So this is the just right talk. On the one hand, you have these small baby problems that your application probably sees even 1 out of 100 requests. No one request that a user makes into your application has a 100% chance of succeeding. So whether that's because they provided input that's looked right when it came in, but then you get like 5 steps in and you're like, I can't do anything with that. Whether you're in a very bad race condition, or whether you just have a network blip, you can't have confidence that any one request is actually going to succeed. So you'll want to have ways to retry requests within your system. Those small daily failures are not part of this talk. On the other hand, we're also not going to talk about massive catastrophic failures, the times that I hope you never experience when your production database goes away and you discover you have no backups, or if aliens ever choose to abduct an entire AWS availability zone. We're not talking about that. So what are we talking about? Oh, sorry. Even though this is the just right talk, it may not be just right for you. A lot of these decisions when you're under stress, when your application is under stress, have direct bearing on your product, right? It's your business. When you have to make hard calls about who you're going to serve and what ways you're going to fail, that actually really has an impact on the product you're selling to users. So I've been very lucky to work at 2 organizations that genuinely care about creating great experiences as much as we can under duress. So these tools that I talk about are specific to that. So what am I going to talk about? I'm going to be talking about a set of 7 tools I've seen used pretty frequently to allow you to shed load, to gracefully fail, and to protect struggling services within your ecosystem of applications. All right, so the first one I'm going to talk about, the first one I'm going to talk about is maintenance mode. So maintenance mode is your hard nope, your fail whale. Put a pretty picture there, but please put a link to your status page, your help page, whatever you're going to do to help your users understand why they can't do anything. The key thing for implementing this is to have it be a single switch. For us, we implement this as an environment variable. We want it as close to the running process as possible. If you have to call out to your database to figure out if you should handle the fact that your database is down, you're probably not going to be in a good situation. So the other nice thing about this is it's a single switch. You don't have like 50 different things you need to configure in order to get that nice error page up. And that's helpful at 2 a.m. The next thing I want to talk about is a read-only mode. Most of our applications that we build are designed to alter a different service. So the plurality of us, I would imagine that's going to be a relational database. The work that your application does is to record some state that the user would like to change and then eventually retrieve that. But it may not be a relational database. It might be another downstream service. You might be pulling in files, transforming them, putting them on S3. You might be sending out credit card charges. Whatever the work that your application is doing, think about what you could do if that ability to modify that goes away. Are there questions you can help your users answer, such as, do I have a shipment on the way? I got this weird error when I tried to charge my credit card. It looks like your billing system is down. Did it go through? So read-only mode can really help with that. But of course, if you answer that question for a microservice, the question of what can I say if something is down, for a microservice it might be nothing, right? That service might have no stored state. For the Rails blog kind of size, this might be a really useful tool. And then as you get bigger, this is probably a far too large hammer for you. Again, keeping this as close to the running process as possible and having it be a single switch means that for us, we would do it in an environment variable, but again, it's too big of a hammer for where we are right now. So instead, we go for feature flags. So usually when we think about feature flags, they are for flagging in individual users into new features, doing gradual rollout. But there are different levels of feature flags that can be useful to consider. So first is that user. You're flagging them into your shiny new UI, perhaps. But you can also have global feature flags where, if you need to turn off billing, you can turn it off. What if, let's say, selling new features, or selling new products is a feature flag, and you can just flip that off. The other one that is more useful when you need even finer-grained controls is thinking about what groups of users might need to be flagged in and flagged out. So I work at Heroku. The work of our application is to deploy users' code. So we are launching containers onto EC2 instances. So for us, relevant groups would be people who have apps deployed in Japan, people who have apps deployed in Oregon, people who are deploying Ruby code, people who are deploying Node code. We have those predefined groups working with product to make sure that we have the ability to narrowly support users who are most likely having failed experiences without causing other users who aren't experiencing any issues to see massive error pages. So what would this look like? So for us, we have a model. For us, we have this model talk to a data store, but you don't need this to talk to a data store. You just need to answer whether a setting is on. So for us, application get is billing enabled. You could have it talk to your Redis. You could have it talk to S3. You could have it curl for a specific file name in an S3 bucket. Whatever method of getting that data is going to be most resilient for you. So if you know that your application is really vulnerable to database Redis outages, then maybe you go the S3 route. With groups, really what we want to go for is simplicity at 2 a.m. So what we're not doing here to see if billing is enabled for the European Union, or for, this would be more likely for all of Europe, would be, what we're not doing is we're not saying, hey, application setting where the region is Europe, get billing enabled. We're just saying, hey, the only thing you need to know when you are told at 2 a.m. to disable billing for Europe is this string. In some cases, remembering a string is more complicated than the SQL query, but when you're under stress, we find the long string is the better option. Rate limits. So rate limits protect you from disrespectful, malicious traffic, right? They are your line of defense against denial of service attacks. And really for keeping your customers from hurting the performance for other customers. But they can also allow you to shed load. You want to be able to, if you need to drop half of your traffic, to drop half of your traffic. You want to enable something like surge pricing. We have this happen to us from AWS all the time. If they don't have the resources to give us a new instance, they make us wait. And we're sitting there retrying a particular endpoint to see, hey, is it available now? Is it available now? Is it available now? But what that makes us do is think very carefully about which instances we need. And, if they need to cut our ability to get a new instance, they just cut our ability to get a new instance, and it's on us to figure out what we want to do in that scenario. So this is really useful for protecting yourself under load. The other thing that we try to do is prefer internal traffic. For us, we have an array of services that compose what you might experience as Heroku. Behind the scenes, it's a whole bunch of different things working together. And if they can't work together because one of them is rate limiting the other, that's not good. So we do prefer internal traffic so that when we get under load, we are still trying to act as a coordinated set of services and not presenting this weird janky experience where something is failing somewhere and we don't really know. So we do this through setting default rates for our entire application. The difficulty in being able to drop half of your traffic is that most of your individual users have custom rate limits, right? So how do you, with one button, one switch, cut half your traffic? So this is where we have a default rate. So let's imagine we're going to set our default rate limit as 100 requests per minute. Kind of low, but we'll go for it because I like easy math. So what that would mean is that, your average customer is going to, when we ask, hey, what's this customer's rate limit? They get 100 requests per minute. And let's say this customer really has some legitimate problems with only being able to make 100 requests per minute. So we double that. We have a modifier on the customer that says you get double the standard rate limit. What that leaves us with is, on your average day, that customer gets a rate limit of 200 requests per minute. And so let's say everything's going along fine until we hit some rough water. We're under load. We want to stay up partially. We have no options. And we know that we're going to stay up if we can drop half of our traffic. We can set the default rate to half of what it currently is. So if our day-to-day default rate is 100, set it to 50. And then all of a sudden that customer is down to half of what they were. Obviously this isn't something you want to do, but it's better to be 50% up than totally down. Another tool is the ability to stop non-critical work. So let's say you're hitting limits on your database, you're maxing out compute and you can't get more, or you're hitting limits of some other dependent service. If that is exacerbated by work that really doesn't need to happen now, you should be able to stop it. We have a lot of reporting mechanisms that really don't need to run now. We also have a lot of data cleaners. They don't need to run now. Sometime in the next 24 hours, yes, but hopefully, we'll be back up at 100% in 24 hours. So for us, we have a setup where based off of the name of the report, so let's say we have a monthly user report that gets run. That class, monthly user report, would know to check this before it does any work. If the setting returns false, then it's just going to exit out. It's going to say, nope, I'll wait. It's okay. I don't need to do anything. And it'll retry eventually on its set schedule. everybody has to deploy code that they're not 100% confident in when, confident in at a certain load level. Certain users, for us, our big unknown most of the time is our largest users. We have code that goes out to staging and sometimes out to production where we think it's going to work for that user that has 20,000 apps. We're not, hopefully it will, right? And there are obviously ways that we can get to 99% surety, on that. It's certainly something that we should probably be working to get to, far higher percentage certainty. But for, whether it's the SQL that you're shipping that kind of has your hair going up on the back of your neck, or, a feature that you're worried won't hold up under load, right? It's fine for now, but what happens on February 1st when all of the reporting scripts start running on it? If you're scared of it, put a flag around it. For us, we are usually sending out code that is trying to do something similar to what's already in production, and we really like the scientist gem by GitHub. It gives us metrics about performance of the new code versus the old code, and then we can just use the scientist gem to turn off the new code if we run into issues. Finally, circuit breakers. So circuit breakers allow you to be a good neighbor to your downstream services. They allow you to not break them, and they allow you to protect them as they're struggling to come back up. So what are circuit breakers? The first type of circuit breaker that you'll usually see is a responsive shutoff. So if you have wrapper code around calling down to a downstream service, maybe as I've been using the example of billing, you're calling down to your billing service. Let's say you've been noticing, an increase in timeouts, or your latency is going up, or you're getting more 500 errors than normal. You can configure your circuit breakers to watch for particular metrics, and if they reach a certain threshold, they'll stop sending requests down to that downstream service. The great thing about these is that they allow you to have a more controlled experience within your application, and it's a faster experience than your metrics determining that a service is down, someone gets paged, someone actually answers that page, someone gets onto their computer, and someone finally figures out, okay, let us stop even trying to communicate with the billing service, and instead just show an error that says, I'm sorry, we can't charge your card right now. Once you have responsive shutoffs in place, using hard shutoffs, so these would be manual triggering of your circuit breakers, can be really helpful. They allow you to protect your struggling services as they're coming back up, even though your circuit breakers might think they're working, but they're not. And so what that looks like is if you have, let's say you have a client class that wraps your billing service. Every client class will have a dedicated circuit. There are plenty of gems out there that will help you create these circuits. And then having some manual way of triggering these to close or open them allows you to help those times when you know that there's no chance that the billing service is actually going to do the right thing. So with all these tools, we want to consider implementation. We have a bunch of different options for using them, or for implementing them, whether they're in your database, whether they're in your caching layer, environment variables. If you need to modify and deploy code, that counts. But make sure that these are in the right place. So as I mentioned earlier, use an environment variable if you think that it's going to help you perhaps use an environment variable if you think it's going to help you deal with a database being down. Similarly, maybe use a caching layer if you're trying to protect a downstream service. Hopefully don't call down to the downstream service to figure out if it's down. There are also a good number of caveats with these. They're not always perfect and what you hope and dream for. The first caveat I want to share is visibility, right? So I started this talk with this nice, pretty image. But if you'll notice, I have not talked about actually getting you that view of what the knobs and buttons are actually set to. And that's incredibly important, because at 2 a.m. you should be able to run a single command or open up a browser and know what is turned off and what is turned on. If you don't have that, then you're pretty much flying blind. And that's not a good place to be. So consider visibility. Build something. It can be hacked together. Next, does it actually work? A lot of these things, they're only going to trip or be flipped in bad scenarios. Hopefully you're not hitting those all the time. Hopefully you go months, even years, between actually using these. And you really may not have much confidence that they work. I can tell you from experience, testing and staging does not guarantee that they work in production. And while it's hard to be on stage and say run game days when we do not really run enough game days, if it's a critical switch, that's really your only mechanism of guaranteeing that it's working, and then it doesn't have, a dependency that you didn't think of. The final point I want to make is that you are trading knowledge for control here. Once you start making your application more configurable at runtime, the less confident you can be that it will work in predictable ways. Fundamentally, that's what we're doing here. We're making your application more adaptable. We're giving it more and more options of how it can behave, and so you're going to be less confident that it will behave in a particular way. So, for example, how do you unit test this, right? Have you tested for a particular user when flagged in to 3 features flagged out of another 2 under a particular rate limit with 2 downstream services down? No. And you don't want to write that test. You'd be writing millions. And so more than just unit tests, keeping production and staging and development environments all in sync is a problem I've never seen an organization solve well. So you really are losing some degree of knowledge about how your application is working and will work for the ability to control it, to operate it. But that being said, this is a deal I will take any day. I would rather have the ability to alter how my application is behaving to keep it up, halfway up, giving a decent error message, than to be sitting there twiddling my fingers, knowing the exact and particular way it is down, and not being able to do anything. So, thank you. I hope you've learned something, been inspired to think about ways in which you can modify your application. And I wanted to also thank the Heroku Sydney office. We have some representatives here. And if you go to bit.ly/RubyCon and fill out a survey, we are, I believe, out of swag here, sadly, but we will mail you swag. So make sure you take a look. Yes, I am amazed at the amount of t-shirts that I'm sure we're going to be mailing out, hand mailing out, but we're excited to do that. And I will love to answer any questions that you have outside during the break.